Thank you, panelists and Vielka, for a fantastic panel. I wish we had more time to talk about those issues, all important issues of equity. But we'll move on to the next panel on integrating CS across disciplines in K-12 classrooms. And thanks to Digital Promise, I know I have some friends. If y'all could just wait for just a minute. I have a few opening remarks. I know we have some friends from Digital Promise. This image is from their recent report on computational thinking. So I'm Shuchi Grover. I'm a researcher, and I was trained right here at the GSE. I did my PhD in learning sciences and technology design with a focus on computational thinking and computer science education, for middle school especially. Since then, I've worked on several NSF projects on various aspects of computational thinking and computer science education, but more recently, I've been working on several STEM plus computing projects of NSF, and in fact, I have colleagues here in this room. We're working on things like integrating computational modeling in high school physics to study kinematics. We're working on pre-K learners, little learners working on STEM activities and how we might integrate computational thinking in those activities for pre-K learners. And now I'm fortunate to work with TILOS in some capacity to integrate computational thinking in their teacher education programs here at the GSE. And so feel fortunate to be doing all of this work, and especially with looking at equity at the core of this work. So before we start the next panel, I just want to frame, as you can see, I'm catching up on my Oscar movies here. I just want to talk about three big ideas or questions around this idea of CT integration. And don't worry, these are not warnings of any kind. They're just meant to be sort of idea starters or vetting our conversations on the how, what, why, when of integrating CT into the subjects. I know there's been a lot of conversation in the US in general. The discourse around computational thinking has been mostly around computer science education. I want to push us to think about computational thinking across the board. And so the first idea is CT's payoff in contexts other than CS. Now, we all know that out in the real world, the payoff in non-CS contexts has been huge. What does that mean for K-12 learning? Now, it's no secret, Roy P. and I, we've written a couple of articles on computational thinking, some of them very well cited. The one in 2012, we talked about the value of bringing computational thinking to the subjects. In a very recent article that was in a book that just came out, we again talk about, that it's in all the contexts outside of CS that CT truly shines in its generativity, from music, math, and everything. And we're not the only ones thinking this way. Peter Denning, I don't know if any of you have read his writings, but he talks a lot about computational thinking actually emerging from the sciences. He says that the computer scientists were late to come to the game, to the party. It's really, computational science that really fueled this idea of computational thinking in the disciplines. And he actually reminds us that Kenneth Wilson won the Nobel Prize in Physics for developing computational models that produced amazing new discoveries. And anybody know what year that was? It was more than 35 years ago, in 1982. And Denning often channels Alfred Aho, another eminent computer scientist, in saying that it's really about thinking about computational modeling in other disciplines. Any field, every field has some sort of interpretation of that field and phenomena in that field. And so basically, computational modeling is any model in that field that simulates or represents computation. So I want us to think about this idea. What do computational models mean in the context of not just science and math, but maybe social sciences and the humanities and such? The second idea is, what is CT from a disciplinary perspective? Is it the same as what we talk about computational thinking in general? So in a recent workshop that was, again, funded by the NSF, hosted by the EDC, a bunch of us researchers and teachers grappled with this question. And we actually also looked at this whole portfolio of research projects funded by the NSF in STEM plus C and iTest. We spoke to teachers about how they were integrating. And what we found was some very key ideas about what we're calling a framework now of thinking about integration, is that CT is often used to understand systems. When it is in the context of another domain, it is about understanding complex systems. It's about innovating with computational representations. Maybe that's a fancy way of saying computational modeling or programming. It's about designing solutions that leverage computational power. It's about engaging in collective sense-making around data. And it's about understanding potential consequences of actions or making predictions. And a lot of the work around STEM plus computing is happening in these ways. And so, again, what does this mean for curriculum design when we think about integrating computational thinking, preparing teachers to think about curricula, etc.? The last one is this idea of technology integration. Now, we all know that EdTech and meaningful technology integration is something teachers have been trying for over a decade or two. They've been doing, it's not just Google Classrooms, but some of them have been doing very, deep integration and very meaningful integration. And ISTE, for example, the International Society for Technology in Education, has been very active in promoting the idea of computational thinking and CT as a vehicle to sort of bring technology into the classroom in a meaningful way. And so, they are very excited about this idea. And one way I found this out, I don't know if any of you saw this. Well, I do know that some of you saw this article that I wrote recently for the EdSurge. It was called Computational Thinking, the Fifth C of 21st Century Skills. And ISTE, ASCD, all these organizations were quick to sort of jump on that. It actually, that article talks about some, I didn't mean for all these to come up, but I talked about some examples. These were exactly the examples that are presented in the article. In the context of language arts, science, mathematics, social science, what might CT activities look like? And some of them involve programming, some don't. But there was a lot of positive feedback that I got on social media from the hashtag EdTech folks. And I just want to share a couple. This is from folks that are doing music ed, and they're saying this is a great starting point for conversations and projects. Then there was someone talking about, purposefully blending coding skills into the classroom. These are teachers that have been trying to bring coding and programming, but now computational thinking gives them a way of a language to talk about it. And again, people talking about this integration. So those are three broad ideas.